The sleek AI tools on your phone are the direct descendants of 70 years of catastrophic, expensive failures. This concept, that human thinking is simply a calculation performed by a machine, reaches back to 1651, when the philosopher Thomas Hobbes first proposed it. But translating that philosophical dream into physical engineering created a cycle, decades of intense excitement followed by total market collapse. To understand why these systems work today, we have to look at the specific limitations that killed every previous attempt. AI history is defined by a recurring collision between blind human hubris and the reality of hardware limits. The field launched in the mid-20th century. By 1943, we had the first mathematical model of a neuron, and by 1950, Alan Turing had proposed his famous test for machine intelligence. At the 1956 Dartmouth Conference, the field officially received its name. Pioneers like Marvin Minsky believed that creating human-level intelligence was an easily solvable problem that would be finished within a generation. That optimism died when researchers hit the computational explosion. They discovered that problems which looked simple on paper required more processing power than any computer on Earth possessed. This created Moravec's paradox. Computers could solve high-level calculus with ease, yet they lacked the basic motor skills and common sense of a human toddler. When these limitations became clear, the hype evaporated. Government agencies pulled their funding, and the discipline entered the first AI winter. We discovered that what humans consider intellectually difficult is often mathematically simple, while our basic survival instincts are a computational nightmare. In the 1980s, the field pivoted to expert systems. Rather than building a general mind, companies invested billions into narrow AI designed for specific tasks, like medical diagnosis or network configuration. This era sparked an internal war. The NEETs argued for clean, formal logic, while the Scruffies insisted that intelligence must be messy and chaotic to reflect the real world. The market settled the debate. These systems ran on specialized Lisp machines that cost a fortune. When standard desktop PCs suddenly became more powerful, these expensive, single-purpose machines became obsolete. The expert systems themselves proved too brittle to update. As the tech failed to adapt, a $500 million market vanished, leading into the second AI winter. Commercial investment cannot sustain a technology if its underlying architecture is too rigid to handle the complexity of the world. While investors stayed away, a quiet shift occurred in research labs. AI was rebuilt on an entirely different foundation. This new era arrived when exponentially faster hardware, the massive data of the internet, and brain-mimicking deep learning algorithms finally occupied the same moment in time. These three elements allowed AI to begin conquering human domains. In 1997, Deep Blue defeated world chess champion Garry Kasparov by mastering the game's pure logic. In 2011, IBM's Watson moved into the nuances of human language and trivia, winning on Jeopardy against the show's greatest champions. By 2016, AlphaGo defeated the world champion in Go, proving that a machine could replicate complex human intuition. The large language models of today represent the accumulation of these specific victories in logic, language, and intuition. Today's systems write code and maintain conversations in ways that meet the highest expectations of the 1950s. However, our current reality still trails the timeline of pop culture. In 1968, the film 2001: A Space Odyssey predicted we would have the fully conscious HAL 9000 decades ago. Modern AI can pass bar exams and mimic empathy, but the original goal, a machine with genuine, conscious, human-level intelligence, remains over the horizon. We have automated logic and scaled the processing of data. Now we are left to wonder what specific requirement is still missing to engineer a soul.